Hey everyone, Mr. Fransky here. We're going to do a little review of log and exponent derivatives, and let's just take a look at kind of where these have come from, and then we're going to land on the problems from the Rainbow review sheets. So students will be able to find derivatives of complex log and exponential functions. Vocab we're talking about is logs, exponents, chain rule, and derivative. So first thing I want to talk about is actually doing some of this stuff using the log properties that we've talked about before. So the key to some of these, like these all come from exponent rules really. A log is just another way of writing an exponent. Remember, if you have like log base 2 of 8 is equal to 3, because if you bring the 2 over here and bump up the 3, 8 is equal to 2 cubed. So asking like log base, I don't know, log base 4 of 64, let's say. That's basically asking, I always write equals x on these, and I say 64 equals 4 to the x power. So it's like, what do I have to take 4 to get 64? Well, that answer is 3. Right, so that tells me that log base 4 of 64 is equal to 3. So a natural log is just a base e. So you can do that with all these problems if you want to. Like natural log of e equals x, bring the e over, so it's e equals e to the x. Well, x is 1, right? So that's 1. So natural log of e is equal to 1, which you probably knew. Natural log of e squared, you can do that the same way if you want to, equals x. Bring the e over, so you have e squared equals e to the x. Well, x is 2, right, because it's the same exponent on both of them. So this is equal to 2. The other way to do this problem, though, is you could bring the 2 to the front. So you have 2 natural log of e, and then natural log of e, we just said is 1, so that's 2 times 1 is 2. Either way you do it, you get the same thing. Doesn't matter. Natural log of root e. Interesting. This is e to the 1/2 power. So I'm going to rewrite it like that. That answer is 1/2, right? Because e to the 1/2 is equal to e to the 1/2. 1 over e, we could write that different too. E to the negative 1. This is equal to negative 1. Not too bad. Natural log of 2e. Now, this is interesting because we could just leave it like that, right? You can't pull the 2 out. That's not allowed. But I could use one of our properties. This one right here might be helpful. I have a product inside. I can change that to addition of logs. This is natural log of 2 plus natural log of e. Ooh, natural log of e is 1. This is 1 plus ln of 2. Or ln of 2 plus 1, but I always like to write the number first. Natural log of e to the 4th over e to the 7th. Lots of choices here. We can use this property and subtract first. So we have ln e to the 4th minus ln e to the 7th. This is 4 minus 7, which is negative 3. Or we could have divided first here. 4 over 7, that is ln of e to the negative 3, which is just negative 3. So as you can see, lots of ways to do things like this, but you should feel very comfortable manipulating log expressions like I just did here. If you want to find a worksheet online, there are all kinds of them. Just Google log problems or log practice, something like that. All right. So, derivatives of things that have exponents that we've been talking about. So the first one, this would be like asking for the derivative of like pi squared. Well, that's just 0 because it's a constant. So this is a constant, so it's always 0 because a and b are constants. There's no x in there. This is asking for the derivative with respect to x, and there's no x in there at all. The next one, x to the nth power, that's going to use power rule, so nx to the n minus 1, right? That'd be like x squared or x cubed or x to the 4th. A to the x, we learned in our derivatives video about exponents. You leave the a to the x alone, then multiply by the natural log of a. That works for e to the x too, right? It's just e to the x, but it's times natural log of e, which is 1, so you don't worry about it. Derivative of x to the x power, this is where we have to use logarithmic differentiation, right? So that's where you would have to do like y equals x to the x, take the natural log of both sides, and then you move the x to the front, and you go through a little bit more. I don't remember the answer this ends up being, but the key that I just want to talk about here is if you have an x in the base and the exponent, you have to do logarithmic differentiation. And you can watch the video on that if you need to. I'm going to make a review video of that as well. But today we're going to kind of focus on the ones that are exponentials or logs to be able to look at these. So, I've got some generalized examples here to start with, and then we'll do the ones in the rainbow sheet. First one, derivative of natural log x. We know that's just 1 over x. Derivative of natural log of 2x, that's going to be 1 over 2x, and multiply by the derivative of the baby function, which is 2. Those 2 cancel. Oh, it's 1 over x. Interesting. Natural log of 5x, 1 over 5x, chain, times 5. That's also 1 over x. Well, this is weird. Natural log of ax. Let's think about what's really going on here. If we use our log properties from before, this is natural log of a plus natural log of x. Natural log of a is a constant, right? So that's 0 plus 1 over x if you take the derivative. So it really doesn't matter what a is. You can either chain it like we've been doing, and the a's cancel, you get 1 over x, Or you can think about it as breaking it up into addition, and then you have 0 plus 1 over x. Either way you do it, you end up with 1 over x every time. I always thought that was kind of a cool little property. E to the x. Derivative of e to the x is e to the x. Derivative of e to the 2x is going to be e to the 2x times 2, but you'll always see that written 2e to the 2x. Derivative of e to the negative x is e to the negative x. Leave it alone, right? We always leave the function alone. Then we multiply by the derivative of the baby. In this case, negative 1. I would see that as negative e to the negative x. X e to the x requires product rule. So 1 times e to the x plus x times e to the x. So the first time we took the derivative of x, that gave us 1. Second time we took the derivative of e to the x, which just gives us e to the x again. So e to the x plus x e to the x. Sometimes you'll see in the book they'll factor that e to the x out. So you have e to the x times 1 plus x. Real common problems that you get here. All right, let's try some of those from the rainbow sheet. Natural log of 1 plus e to the x. So derivative, all these we're going to find y prime. So let's see, y prime here is going to be 1 over 1 plus e to the x. Then we have to multiply by the derivative of the inside function, which is just e to the x, because 1 would give me 0. So I'd write that e to the x over 1 plus e to the x. X e to the negative x, product rule. 1 times e to the negative x plus x times e to the negative x times negative 1, because we have to chain that negative x right there. I would write that e to the negative x minus x e to the negative x. Could factor out the negative x, e to the negative x if you wanted to, but I'm just going to leave it there. E to the power 1 plus ln x. Well, I'm going to leave it alone, so y prime is going to be e to the 1 plus ln x, multiplied by the derivative of the inside function, which is 1 over x. So that gives me e to the 1 plus ln x, all divided by x. Now, there's something you could do here. Remember, addition of exponents is the same as doing multiplication with the same base. So this is actually x, right? E to the ln x is just x times e, right? X times e. And the derivative of that should just be e. The derivative of, because e is a constant, right? So this is e times x, so it should just be e. Do a little bit of rolling around here. This is, if we do the same property, this is e times e to the ln x, which is e times x over x. It is indeed e. But this would be acceptable. It's just that this would be a very common answer for like a multiple choice problem or something. Natural log of sine x, y prime, 1 over sine x, chain, cosine x. Cosine over sine, cotangent x. Cool. All right. Natural log of cosine inverse, r, all right, r prime is going to be 1 over cosine inverse x, multiplied by the derivative of cosine inverse. Ooh, negative 1 over square root 1 minus x squared. Nice. It's kind of gross. You could combine those fractions if you wanted to. Negative 1 over the product of the bottom. Log base 2 of theta squared. So log, I didn't put this on my summary screen, but I should have. The derivative of log base a of x is 1 over x ln a. Remember, you had that extra ln a down there, because if it's natural log, that'd be 1 over x ln e, but ln e is just 1, so you don't have it there, right? Okay, so this is going to be 1 over theta squared times ln of 2, because that's what we have here. Then we have to multiply by the derivative of the baby, which is 2 theta. One of those thetas cancels, so I'd write this as 2 over theta ln 2. Log base 5, t minus 7, that's going to be 1 over t minus 7 ln of 5. Now I should multiply by the derivative of the baby. What's the derivative of t minus 7? That's just 1, so we're done. 8 to the negative t. So derivative there is going to be 8 to the negative t, leave it alone, times ln 8. That's the derivative of the outside function, which is just 8 to some power. Then we multiply by the derivative of negative t, which is negative 1. Write that as negative 8 to the negative t times ln 8 probably. But either way is fine. So that kind of runs you through the problems from the rainbow sheet. I hope that was helpful for a little bit of a log and exponential derivative review. I love you guys. That's why I'm here. Have a great day.